Good morning, judges. Today we are going to present our project, the investigation on the natural dye catalyzed solar cleavage of gunpowder oil in hydrogen production. First, let me explain our flow of our presentation. We will first talk about our inspirations, and then the principles of our hydrogen production method. Then we will discuss our investigation results. Then we will talk about our breakthroughs and advantages, and we have compared our hydrogen production method among the others, and we will demonstrate our application. First, let me explain where our ideas came from. The gunpowder oil problem is very severe these days. When it is disposed to the environment, it will cause pollution. When it is reused for producing food, it will harm our health. Since the scandal broke out in Taiwan, it greatly raised the awareness. So, in our project, we are trying to solve this problem. The air pollution problem is also very severe. If the problem continues, we will no longer have any fresh air to breathe. And the global warming problem should also be blamed on the emission of greenhouse gases. It is because of the increasing demand of energy. And it's because of the increasing demand of energy. In general speaking, both generating and consuming process of electricity can produce pollutant gases and greenhouse gases. So in our project, we are also trying to seek for an alternative energy source which can be produced and consumed in a cleaner way. The energy crisis is also a global problem. It is because of the increasing demand of energy, and fossil fuel is non-renewable. So in our project, we are also trying to find an energy source which is renewable. We have done some research on titanium dioxide in photocatalytic water splitting. Titanium dioxide can split water into hydrogen and oxygen under some lights. It has a very clean energy. It is a very clean energy source, hydrogen, because it can be produced in a very clean way, and it can consumed in a very clean way when it is used in hydrogen fuel cell, because water is the only waste product. However, it is not very popular yet because it has a very low efficiency, and so it is mainly used to decompose organic compounds instead of hydrogen. In atomic level, the reason why it has such a low efficiency is because of the rapid recombination of photogenerated electron hole pairs, and this is not able to utilize visible light because of its low band gap. In our project, we are trying to solve the gunpowder oil problem as well as air pollution and energy crisis problem by enhancing the efficiency of titanium dioxide, by prohibiting rapid combination of photogenerated electron hole pairs, and enhance the solar to hydrogen conversion efficiency by enabling our method to utilize visible light. And we will discuss this now. Now, let me introduce our principles. The band gap theory states that there is a conduction band and valence band in a solid, where the one with higher potential energy is conduction band and the one with lower potential energy is the valence band, and the gap between them is called the band gap. In conductors, there is no energy gap between conduction band and valence band because they are coincide with each other, and therefore electron can flow freely to and from the conduction band, and electron can flow freely, and therefore no electron hole pair can be formed. In insulators, the separation between conduction band and valence band is too large, and therefore it is very difficult to provide sufficient energy for the electron to be excited from the valence band towards the conduction band, and therefore electrons are restricted, and no electron hole pair can be formed either. In semiconductors, such as titanium dioxide, conduction band and valence band are separated in a relatively smaller energy gap. When external work such as light is done, it can trigger further excitation, and therefore electron can be flow from the valence band towards the conduction band, and an electron hole pair can be formed. UV lights possess a high energy content to provide sufficient energy to trigger the photoexcitation. The hole formed on the valence band shows a very strong oxidizing property, and glycerol can be oxidized to hydrogen, and hydroxide ion can be oxidized to hydroxy radical, and the electron can reduce hydrogen ion to hydrogen gas, and therefore both bands can produce hydrogen, and glycerol, which is extracted from the gunpowder oil, can be consumed. There are ways to enhance the efficiency, such as metal ion dopings. It can enhance electron pair regenerations as well as electron trappings and hole trappings. The red arrow indicates the original pathways, while the other indicates the alternative pathways for the electron to flow. We employed chlorophyll as our natural dye for sanitization. electron can be flow from the natural dye towards the conduction band of titanium dioxide, and electron can be accumulated on the conduction band for the reduction to occurs. In our method, we are going to adopt the metal ion dopings and natural dye sensitization. This is our general setup. We use a data logger and a pressure sensor to measure the gas involved in the conical flask. And we also use a temperature sensor to monitor the temperature. And we use a magnetic stirrer to ensure the reaction mixture is homogeneous. And also, this is an O-ring fluorescent lamp to imitate the sunlight source.
And these are the investigation results. From our investigation, we found that the best photocatalyst that exhibits the greatest hydrogen production is 0.4 gram of titanium dioxide. The results can be explained by this comparison table. As you can see that titanium dioxide has a band gap much lower than that of zinc oxide and zinc sulfide. Although iron-free oxide has a much lower band gap than that of titanium dioxide, its absorbance is much lower than that of titanium dioxide. And this is the descending order of the efficiency of these four photocatalysts. Besides, we also found that the best water to Gaussian-1 ratio in the reaction mixture is 9:1. While the best metal ion doped titanium dioxide is copper-2 ion doped titanium dioxide, calcined at 400 degrees Celsius. These are the advantages of metal ion dopants. It can narrow the band gap, induces redshift of absorption spectrum, and utilizes visible light. Besides, it can enhance regeneration of electron hole pairs as well as the electron and hole trappings. Most importantly, it can increase the electron mobility. And this is our result. As you can see that copper-2 ion doped titanium dioxide shows the best performance on hydrogen production. The reason for why that when it is heated at 400 degrees Celsius, it works best in hydrogen production because it's neither slightly doped nor deeply doped. When it is heated at 400 degrees Celsius, it shows the ability in reducing the band gap for photocatalytic water splitting reaction. In short, copper-2 ion doped titanium dioxide shows the capability of electrons and hole trappings. Its high quantum yield and peak absorbance explain that why it shows the best performance on hydrogen production.
Among the three natural dyes, we found that chlorophyll exhibits the highest performance in hydrogen production. Here is the spectrometry analysis. We can see that chlorophyll has two absorption peaks. The reason why chlorophyll is the best sensitizer is that chlorophyll has 10 conjugated double bonds, and it has the ability to chelate due to the presence of lone pair electrons on the oxygen atoms. It has two absorption peaks and a relatively high quantum yield of 25%.
We found the best pH medium on copper-2 ion doped titanium dioxide alone is pH 14. This can be explained by the point of zero charge. When the pH value is greater than 6, there are more hydroxide ions in titanium dioxide, and more hydrogen can be attracted to titanium 4 ion and reduction occurs. Besides, we found the best pH medium on copper-2 ion doped titanium dioxide sensitized by chlorophyll is pH 10. If the condition is too acidic, the nitrogen ion will be protonized and magnesium ion will be lost. And if the condition is too alkaline, the ester group will be lost due to alkaline hydrolysis. In conclusion, we found that 0.4 gram copper-2 ion doped titanium dioxide calcined at 400 degrees Celsius, sensitized by 9U3M chlorophyll, and to water and glycerol in a volume ratio of 9:1, exhibits the highest performance.
There are some breakthroughs and advantages in our method. Apart from the 3% of UV light, we can successfully utilize 43% more of visible light, and we convert waste oil to clean energy, and we develop a one-pot system which is simple and convenient. This is the solar spectrum, and we can see that only about 47 to 48% of sunlight can reach the ground. We have investigated our reaction mixture under different light sources, and we found that all visible light can be utilized in our method, and totally 46% of sunlight can be used, which means more than 95% of the sunlight reaching the ground can be used in our method. Also, we can convert waste oil to clean energy, as glycerol is consumed and it is extracted from the gutter oil. As you can see, this is the gutter oil and this is the pH buffer. And it can undergo alkaline hydrolysis. as you can see, glycerol can be extracted. And the upper fraction is the salt, and the colorless fraction is glycerol. And you can see the glycerol experiences a series of oxidation and decarboxylation, and finally it decomposed to hydrogen and water. Also, we developed a one-pot system which is very simple and convenient. This is a windmill to ensure the reaction mixture is homogeneous, as we can't use the magnetic stirrer in our real life. And this delivery tube is to store the hydrogen we evolved in the reaction mixture in a hydrogen tank, or it can be connected directly on the hydrogen fuel cell. And it has a very high mobility, which can be carried easily, which means it can be used in both domestic and industrial situations.
In our method, there's no toxic chemicals involved, and the reactants we use are almost in unlimited supply from Mother Nature. Our method is cost effective. Our method is safe because the chemicals we use are non-toxic, such as water, glycerol, chlorophyll, pH buffer, and titanium dioxide. And our method has a lower risk of explosion compared with the traditional steam methane reformation, as there is no sulfur and methane involved in our method. The reactants we use are in abundant supply. For example, a large amount of food waste is disposed every day, and glycerol can be extracted from the food waste, and water is in unlimited supply, which can be obtained from the sea and rivers. And we can extract coal from nature and also some vegetable food waste. And titanium dioxide exists readily in nature and is abundant and cheap. It will not be consumed in our method as it acts as a photocatalyst. As I've mentioned, most of the reactants required in the reaction mixture have an abundant supply, and low cost is needed for obtaining or extraction of some reactants. And for every 10 liters of hydrogen produced, it costs only approximately $3 Hong Kong, and it only counts for the titanium dioxide and hexane used.
We have compared our method to photobiological water splitting, steam methane reformation, and the electrolysis. We can see that in steam methane reformation, it requires a very high pressure and temperature to operate, and it is very dangerous, and the maintenance cost is very high. In terms of the availability of reactant, our method is extremely high, while platinum electrodes are required in the electrolysis, which is very rare and expensive. The cost of our method is only $3 Hong Kong, but that of the other three methods is very high. The risk of our method is low because reactants involved in our method are chemically stable, but methane in steam methane reformation can be explosive. Most importantly, our method can solve the food waste problem, as we convert gutter oil into hydrogen fuel, which is a clean energy, and our method is a renewable method.
The uses of hydrogen gas are important in our daily lives. We can use hydrogen for many different ways. For example, we can use hydrogen gas for hydrogenation to produce margarine. Besides, hydrogen gas can be used in hydrogen fuel cells as well as the fuel cell cars to provide energy. Besides, hydrogen gas can be used as rocket fuel to launch rockets. And this is the end of our presentation.